Hi there, this is John Bishop, and I'm with Dr. Nancy Flournoy and her husband Leonard. And so we're going to be jumping right into a little video first about this patch that Lifewave makes called the Alavida patch. And we'll watch this video first, and then we're going to take about 20 minutes to go into a presentation.
Rejuvenate your skin by reinventing the way you treat it. And that begins with a technology that takes a whole new approach to skincare, one that improves the health of your skin from the inside out and the outside in. With 98.6% naturally derived ingredients and a 24/7 approach to skin nutrition, you experience vibrant skin from day one. Alavida, nature and science in perfect harmony. With key ingredients like microalgae oil, rice bran oil, milk peptides, moringa butter, and vitamin C. Working together with our patented proprietary technology to deliver 3 breakthrough products. Introducing the Alavida Regenerating Trio, a moisturizing and anti-aging solution, starting with a daily refresh facial nectar for daytime use when your skin is exposed to the elements. With antioxidants known to protect the skin from visible signs of aging. And nightly restore facial cream for nighttime use when your body naturally heals itself. It helps improve firmness and elasticity and reduce the appearance of fine lines and wrinkles. And finally, the Alavida Phototherapy Patch for nighttime use. It uses light to stimulate acupressure points on the skin, which reduces oxidative stress and helps preserve antioxidants in the body, both of which promote the regeneration of your skin's radiance. Developed with a 30-year cosmetic industry veteran, Alavida applies complex science to naturally derived ingredients, proven to have a positive impact not just on the look, but on the health of your skin too. And just as important as the ingredients we put in are the ones we've chosen to leave out. Alavida contains no parabens, sulfates, phthalates, synthetic or artificial fragrances, ureas, artificial colors, or dyes. But most importantly, these 3 innovative products provide immediate and long-lasting results, including a significant improvement in hydration, regeneration of radiance, firmness, and overall appearance. Alavida, a beautiful merging of nature and science. Contact your Lifewave distributor or learn more online today. Lifewave.
Okay, that's how we'll start things off. All right, so Dr. Flournoy, I'm going to turn it over to you. I'll let you share your screen.
Okay.
And you should be able to do that now.
Yeah, just, okay. So, do you see it?
Not yet.
Let me just do this again.
Okay, try it one more time.
Yeah,
There we go.
how's that?
Perfect.
Okay. Okay, well, thank you, John. Thank you for giving me the opportunity to talk. I'm Dr. Nancy Flournoy. I have a PhD in biomathematics and a career of working in clinical trials, both in the application and in experimental design for clinical trials. I got into the patches primarily initially because of my husband's pain in his hands, but we're going to talk about Alavida today. And to follow up with the slideshow that you just had, I'll just say a little bit about the skin. The Lifewave company decided to promote this product as a skincare product, but and there are lots and lots of pictures online, you can see lots and lots of evidence that in fact, if you use the Alavida for some period of time, your skin does look firmer and fresher and healthier and younger. So what I was interested in though was the effect on the organs. And there is evidence, they have research evidence that the patches do actually affect organs as well as the external skin, which makes sense if you look at this outside layer of your skin is the epidermis, epithelial cells made up of epithelial cells. And epithelial cells cover not just the outside of the skin, but they cover organs, intestines, vascular, your arteries, your veins, they are like everywhere. So I wanted to understand, even though the company wasn't promoting Alavida for the benefits to the organs, I wanted to see what I could learn about what they actually do. And so I invite you to join my search for greater understanding. I am not a biologist, but as a scientist, I read what I read and then I get critical of it and I go try and find answers to the questions that are brought up. And I have gotten more information than I had to start with, but I still find that a lot of the things I find make me want to ask more questions. And so I start out with this question about what do the published claims about Alavida's effects on the organs actually mean? And I'll explain to you too why I have to ask that question. So let's start with the published paper. Excuse me, it's not published. They have a research paper called Lifewave Alavida Non-Transdermal Anti-Aging Patch Improves Cellular Functional Status in Different Organs. Well, this is a pilot study that was done in 2015, and the authors are Sherry Blake Greenberg and Homer Nazarin. And it turns out these two authors also have papers on a number of other patches. They have papers on the SP6, they have papers on glutathione, several of the different carnosine. They have several different papers, which are all longer with larger sample sizes than this particular paper. But this particular study, if you see here, just involves 10 subjects. So it's definitely a pilot study. And all of the studies that these authors have done together involve a piece of equipment called the electrointerstitial scan. So if you look at what the claim is, improves cellular functional status, and you have to say, well, what does that mean? Well, you don't measure status. So the measurement, this has to be some sort of summary of measurements that are being taken. And so I wanted to know more about what this piece of equipment actually does. But I'll tell you right to start with that the paper considers all of these different organs, the kidneys, both left and right, adrenal glands, left and right frontal lobes, pancreas, liver, hypothalamus, pituitary, and thyroid glands, and also the intestine. And of all of these different organs, they report pre and post measurements. I'll give you more information on the design, what they actually did in a minute. But comparing subjects to themselves, they report significant differences in all of these different organs except the intestines. Now, I still don't understand statistical differences of what, but I can tell you that to get significant differences when you have 10 subjects takes a lot of consistent measurement between the 10 subjects. It is very, very hard to get statistical significance with 10 subjects. So even though I'm not quite comfortable with what it is they are measuring, I am quite convinced that they're seeing something, that something is changing in each of these organs, again, except the intestines. So let's try to dive a little deeper into what's going on here. So the research methods in this little paper was, they say they do the testing every week, and they measure the baseline versus the subsequent studies. Patients, the subjects took the Alavida patch nightly for 5 consecutive nights a week. They took 2 nights off and went for 30 days. Now they took the 2 nights off because all of these patches, our recommendations are to pulse them, to give little breaks so that your body doesn't become accustomed to getting the little light signals and forget to pay attention. So that is consistent with common recommendations from Lightwave. And their hypothesis was that if you did all of this, you would get a significant difference in the measurements. Okay, so that's the statement. So what about these measurements? Well, this piece of equipment called electrointerstitial scan, EIS, is much like an EKG, but it measures the resistance. So you've got an electric current going through the body, and they measure resistance that current meets as it goes through the body, but they use a very low voltage direct current. And I'll mention a little bit more about that later, but one of the things that is said is that this direct current, this low voltage direct current, is not able to penetrate a cell. So when it comes to a cell, it goes around the cell. And so certainly the amount of cellular matter in your body as compared to space between the cells is going to affect those measurements. So most of the current goes around the cell and through what? Well, outside the cells is this substance called interstitial fluid, and we'll talk more about that in a minute. They also report that the stimulation causes a release of sweat. And sweat is involved with the interstitial, with the movement of substances between cells and inside cells and outside cells. But why they kept bringing it up in this report, I don't know. I did find that they had done, that there is a published report on 600 healthy subjects to provide by baseline data. So I would say that it's pretty, and healthy subjects, this is a pretty big sample size of healthy subjects. So they have a pretty good idea as to what is normal and what is not normal, both on having the current go too fast and the current go too slow. Now, the thing that really stumped me in trying to find out what was going on is when I first Google on this piece of equipment, the first thing that comes up is this site that has a big fraud warning. Well, you know, that was kind of upsetting. But I just, you know, I suspend my disbelief because I know there's lots of very arrogant people out there who think because they haven't heard of something and they don't understand it, that it's got to be
Can't be true.
Can't be true, yes. But so the next thing, when you look at the Google search, you should come up with a paper by this guy, Albert Marek, and he actually has two papers. The second paper was harder to find. The first paper is earlier and it's very critical. The second paper, not so much so. But the reason I didn't, I wasn't stopped by the first paper is that he says there's a lot, the documentation he found had a lot of mathematics in it. He didn't understand the mathematics. So I'm going, well, if you didn't understand the mathematics, why are you reviewing the paper? So again, I thought, okay, I just have to keep going here and find out what's going on. So finally, I did find out it was a French machine, and I started looking. You see the .fr here in the website. I started looking for information about it from France, and I found this picture with which is a description of where they put the electrodes and how you know, send the current through the body. And so they have these 11 pathways and the 6 electrons, and it's the same setup that these two authors used using this piece of equipment in the studies that they did for all the different patches that they looked at. So again, you know, well, one of my first thoughts was, so you've got to get from these measurements to the different organs. I mean, at first I thought maybe they triangulated around, you know, the bladder and the pituitary gland and the other things that they looked at. But it's the standard set of measurements, which what I'm thinking now is they pretty well span the body, and that what they must do is interpolation between them to where the organs are. But it's so an open question is, you know, how do you actually get from these, there's only 10 different pathways shown here, but how do you get from these pathways to an actual conclusion about the stomach versus the intestine? Okay, so that's an unknown. So again, the currents are going through the body, skipping around the cells in the interstitium. And this is tissue that connects and supports your more solid tissues, and also serves as a transport medium for your nutrients, your waste products, and for signaling molecules that are going to be telling your body what to do. Having that bit of information, I thought, well, okay, let's now look at the biology of the epithelial cells and see if we can get some idea as to what that current is doing as it goes through the body to tell us something about the health of these organs. So animals have 4 kinds of tissue: connective tissue, muscle tissue, nervous tissue, and the epithelial tissue. And the epithelium is a thin, connective, protective layer of cells, just like your skin on the outside is your big protection, but that's the same thing's true of all your organs and we'll see some pictures. So you have a number of different ways in which the epithelial cells put themselves together into a tissue. It can be a single layer, they're kind of flat, or they can have these little cube shapes. They can be, you know, one layer or multi-layers, or they can form like little columns here and be tall. and they can be transitional. And I will show you some examples. So here's the simple cubule formation. And that's the kind of form that the tissue will take in your glands and also in your kidneys. Whereas this columnar formation occurs in your respiratory tract and in some of the tubes of the male reproductive tract. And then this transitional tract is interesting. It lines the pelvis of the kidney, the uterus, the urinary bladder, and upper parts of the urethra. And so when the transitional is really flexible and it'll stretch. So when you think of getting a full bladder, what's happening is this material stretches out and looks more like the flat, elongated tissue than the cubes. But when you relax and your bladder is empty, then it gets more jagged looking up and down. So all of these different types of functions, but they're all cells that are tightly packed together. So getting material around and through them is not physically so easy. They're all avascular. That is, you don't have a blood supply here. The supply of oxygen and nutrients is coming through the interstitial space that's around the cells. And because it's the tissues they're covering and linings, you have one surface that doesn't touch any other cells, and the other one is free. And and opposite the free surface, you have a layer that is connected to connective tissue. And the kind of the glue that's made up of carbohydrates and proteins gets secreted by the epithelial cells and the connective tissues together. So in combination, they create a glue that holds the two components together. So what do they do? Well, when I gave this talk the other time, I just gave a list of these functions. And as I read it through, I thought, well, I don't really understand what I'm talking about. So I went to the dictionary and looked these terms up, and it explains some things and leaves, again, a lot of questions as to what they actually mean in the case of this tissue. But protecting, we can all understand protection is protection. It's nothing more specific there. Secretion. Well, the secretion is the process of segregating, elaborating, and releasing some material, either functionally specialized, like saliva, or isolated for excretion, such as urine. Well, here we're thinking about secretions from the epithelial tissues into the surrounding organs or back out into the interstitial spaces. Absorption, the first definition I found for it was the interception of energy waves or sound waves. And I thought, oh, wow, this could have something to do with Lifewave with its light technology. But then I also found this definition, which is more common, the act of taking up or in by a specific chemical or molecular action, especially the passage of liquids or substances through a surface of the body into the body fluids and tissues. So this sounds a lot like what the epithelial cells must be doing, that is taking substances through through itself into the cells or out to the interstitial fluid. Well, excretion, if it's taking stuff in, it's taking stuff out. So it functions, it's part of getting the waste material from the cells two places, the waste material out to the lymphocytes and or back into the vascular system so that it can go out with the blood. Filtration, well, I mean, that one leaves a lot of open questions, because it tells you that not everything gets through, and that the epithelial cells itself have a role to play in deciding what's going to pass through to the organs or out from the organs and what is not. And then this word diffusion. Well, I found a chemistry definition and a physics definition, and either could be relevant, and I'm not sure which is intended to be emphasized. But in the chemistry, the definition is the process whereby particles of liquids, gases, or solids intermingle as a result of their spontaneous movement caused by thermal, that's heat agitation, and in dissolved substances move from a region of higher to one of lower concentration. Okay, so it's talking about mixing stuff together. In physics, again, we have the reference to light. It's reflection of a light by a rough reflecting surface. I'd like to think that it was a reflection to a reference to the light wave light technology, but I'm kind of guessing it's not. And again, the transmission of light. And the other thing that's really interesting is sensory reception. So it is the tissue that is receiving the nerve impulses in the nose, the taste buds, and other places where we get sensory information coming directly into the body. So that's a nice collection. Again, sort of more questions than answers. So let's just look at the artery, veins, and capillaries. So this is just an example of where we have, we have things going on here. So here's the vein, the blood's coming down, it gets to the capillaries. Now, blood carries oxygen. You're trying to get the oxygen to the cells. And this action happens down here in these capillaries. And then blood goes into the capillaries, and then it comes out and comes around the other. And you see this layer right in the middle, lining the inside surface of the artery and the vein. Those are your endothelial cells. So within the vascular system, they are playing a role between the inside of the veins and the arteries and the more substantive part of the cell, the artery vascular walls themselves. So here we have the endothelial cells as an example of protecting an organ, but we have this function where we want the oxygen to come out of these, oxygen and nutrients to come out of the vascular system, get into the interstitial fluid, get from the interstitial fluid into the organs, and then for the waste products to come back. And so it's that whole transition that is the pieces that I've just started to try and put together. This is an interesting one. This is again, so up here, you're in the middle of a blood vessel, and the shear stress means the blood's flowing from left to right. And all these little yellow dots, if you can't read them, are sodium molecules. And you have these things that look like little antennae. So down here at the bottom, we have our epithelium. So that's the surface of the cell, the vascular cell wall, the wall of the blood artery or vein. And then you have these things growing off of them that kind of look like antenna. And so here's a healthy one with all these little protrusions out each direction. It's got a big, long, ugly name, which from what I read, they're just coming to understand. And then this one over here, you notice some of the arms have kind of been ripped off. I mean, there's more space and it's not as tightly structured, and it has many fewer sodium atoms in it. And so the way I kind of picture this is it's like if you go out in the bay and you have a lot of seaweed, then you get a lot of fish in the seaweed and it sits there. But if you take away the seaweed, then the fish goes somewhere else. And so if you rip these strings of molecules that are the antenna off, then your sodium atoms are just going to flow right on down the bloodstream and not hang around to serve in the function of transporting things from inside the blood vessel to outside of the blood vessel. And so they keep referring to the sodium pump, which is you have the positive, the sodium molecules are positive, and the phosphate is negative, and the balance between the two is critical for getting things transported through the epithelium and from the interstitial tissue once it gets out here into other molecules. So again, most of the sodium is going to be transported between the cells. So how tightly these are packed together matters. So this is a little picture trying to, again, say, what does it all have to do with Alavida? And there's the claim that Alavida reduces oxidative stress. And so what is oxidative stress? Here we have a picture of the fast the fast current going right through the cells in pretty straight lines. And we have the low wave intensity, which this machine is picking up, kind of going around the cells. And these are cells with normal oxygen levels. And on the right, we have cells that have decreased oxygen levels. And if you see what happens with the decreased oxygen level is the cells are bigger. Each of the ones is bigger relative to the space in between. And so instead of having this big, thick green line coming through that you're measuring, you have resistance, and you're only getting this little bit of the current coming through. And so this shows how the current is going to measure the fact that there's not enough space between these cells to be able to transport the things that you need to transport. Now, so the paper on Alavida was very short. It looked like it really had sort of been stopped without really being finished because it didn't have any references or anything in it. But if you go to their paper on carnosine, they explain more about this piece of equipment. They told me that it was a piece of French, it's a French device that is classified as a medical device in Europe and the United States. And somewhere else I found it was also classified that way in Canada. And I believe also in Korea, because there are a number of papers in Korean that I couldn't read. And they describe its main functions are to read the different processes going on in the body, hyperactivity and hypoactivity. So I think that just translates to, is there too much current going past these organs or too little current going past them? It also says you can use this machine to measure biochemistry and hormone levels. And I didn't see anything about that in terms of of how it does that. Again, I never did find the company's website. So, so presumably somewhere there's more information, and did I go up or down? So it does measure resistance. I think I've got some ideas to what that means now. We've sort of seen a picture of how that relates to the interstitial volume. But what it has to do with pH, I'm not sure. And then it also, they also make the claim that it measures body composition and the sympathetic and parasympathetic influences of the autonomic nervous system. Excuse me, and I don't know how it does that. So I'm left with some unanswered questions. So what do these measurements actually tell us? I have no doubt that pre and post using the Alavida, these measurements change. You know, what the resistance changes in individuals. That's, you don't get statistical significance with 10 subjects without essentially all 10 of them changing very much alike. So what do these measurements have to do with the epithelial tissues and the organs? Well, you saw me start to try and piece that together. I wouldn't say I have done a great job of it, but at least it's a beginning. And as I said, I don't know what it has to do with pH. Where is the company website? Where is the company? And then somewhere I saw Lifewave claim that Alavida reduced oxidative stress and preserved antioxidants. I can't find that reference now, so I'm not sure where I read it or heard it. I think we've seen a little bit about how it might relate to oxidative stress, but how it preserves antioxidants, I don't know. And then, you know, what happened to the paper? You know, why wasn't it published? So that's the status currently, and I look forward to learning more and learning anything that you all might find out to help fit the pieces of the puzzle together. Thank you. Any questions?
Thank you, Nancy. Oh, that was great. That's good. Very deep research that you did into there. That was good.
Well, as I say, it should get more streamlined as the understanding gets more complete.
All right.
I'll stop sharing my screen if that's it.
All right, that was a great one for today. Thank you. So yeah, that was a real enlightening presentation for me. I don't know too much about you know, the structure of the skin, and certainly less about the structure of the organs and all those functions. But I can really see that you know, light has an effect, as we know, just from being out in the sun. You know, there's these physiological things that happen when we're exposed to light, and now they're, you know, we've come into this area of phototherapy. How many different kinds of benefits, you know, I think is what we're really hoping for. The things that are not going to just improve, make us look maybe a little younger, take some wrinkles away, or tone up our skin, but I think even more importantly is how to protect, you know, our organs from, you know, damage from free radicals, damage from you know, the things that we're taking into our bodies, because we have so many more things that we eat in our diet today that are not good for us, you know, especially processed food and things like that. So I think that number one, we should really think about what we actually physically take into our bodies as far as food and beverages. You know, I mean, there's a big thing with energy drinks today. You know, people need that extra 5 hour, whatever they call it, 5 hour energy, and I think it's, you know, more than ever, there's a lot of studies coming out about the damaging effects of some of these things that are trying to promote energy or trying to give us more stamina or whatever. And but I think we know that light can be a good thing, or if there's too much of a certain kind of frequency of light, let's say if there's too much ultraviolet light, that can actually damage and age our skin more. So I think that this company is really at the kind of at the, they're not at the pinnacle yet, but they're at the breaking point, I think, of really discovering how something like this Alavida patch can really help us to become more healthy on the outside of our bodies, our skin, but also on the inside of our bodies and our organs and vascular system and things like that. So it's very exciting.
Well, it's one of the more mysterious ones too, though, because
right,
like with the carnosine and the glutathione, they were designed to increase the production of a particular molecule.
right,
And even with the X39 to increase the copper
right,
peptide.
right.
And with the Alavida, we have no specific claim like that. It's going to change one thing. Instead, we have this global reference to the epithelial cells and to the skin glowing. And so it makes you wonder two things. It makes you wonder what they actually designed it to do specifically. And then, and then how that happens in all these different cells.
Right, right.
It's a fascinating sort of departure from the other
Patches, right? Yeah. So Leonard, what do you think about all this?
Well, I think that there are an awful lot of mechanisms that are going on, and for instance, the cells that line your intestine, they get flushed out every 3 days.
Mm-hmm. Right.
I mean,
yeah,
so I just don't know where it's going to go, but obviously it's affecting some important stuff. So
yeah, and it's just hard. Like Nancy, you said, yeah, I think you're right. It's kind of like it's kind of mystery world with what's going on inside. With the
right.
Because we can. I can see the difference, let's say, for the people that I know, who have been using Alavida patch and like my wife, I can actually see, I don't use it as much as she does, but I can see the difference in her skin and, feel it actually, because she's been using it now for, I don't know, I think about 6-7 months now. So I can really see a big difference. You can actually feel it. There's a firmness and stuff. And she had some like kind of discoloration also in her cheeks. And I still a little bit there, but it's reduced quite a bit. So I don't know the mechanism that's working there exactly either, but for some reason that those spots, I guess they call them age spots, they're not as predominant as they were before 6 months ago. So yeah, but definitely I feel like they did kind of put the brakes on the other part of the story, which is really how I think it's more the Alavida patches, right, than the creams that affect that have the positive effects on those organs. So very interesting. Okay, well, that's all I gotta say.
Good.
Well,
okay.
that was great, Nancy. That was really it was a deep dive into the science of that. So
well, I hope it wasn't too deep.
No, deep is good. Deep is good. That's where we want to do. We want to dig deep, find the answers. It helps us to understand ourselves, so we have more confidence when we're trying to explain these things to other people. So it was great. It was a great presentation today. So
Thank you so much.
Good.
okay, thank you. It's great being with you. Okay, so we're gonna do this again. All righty.
Very good.
Okay. Okay.
All
So
right.
enjoy the rest of your evening. Get out there and
Bye-bye.
get some sun.
Bye.
Okay.